Hello and welcome to the Only Fabs channel. I'm Steve, or as some of you have seen us on TikTok, Fitter Steve. So we do a variation from a bit of fitting work to mainly welding and fabrication with things like this behind us. The first video will be the making of a 75-ton ripper tooth to go on a Volvo machine. We're actually making two of these teeth, me and the other welder that we have here. But anyway, I've only videoed my bit. So you'll get to see right from the very start where we just have a load of bits right to the end and the finished product of it all together, painted and ready for the machine. So hopefully you enjoy what we do. Give us a like and subscribe, and who knows, we might see more of each other. So here we go, 110mm shank. First of all, we set the quickie up and trim the excess off to make the nose of the right angle. Then once we've got this off, we set the quickie up to 30 degrees, and as you can see here, we put in the weld prep on. So essentially you have a triangle once it's turned over and prepped at this side. You have a point or a triangle on the end so that you can get the penetration right through into the middle. And here we are, just cleaning a bit of slag off, marking her up, ready to put the nose on. Peter here giving us a little bit of a hand just to get her eyed in. Now we make a strong back so that it doesn't bend and pull when we start to weld it up. And then shortly after, we'll get it turned over on its side. Now that we've got it turned over on its side here, you can see we're putting the run on and run off tabs on. So when we start to weld it up, we can get the weld up to temperature before we actually onto the bit of steel that we're welding, and off the bit of the steel that we're welding at the other end before we stop, because your weakest point you weld is always where you start and finish. So for anybody that doesn't know that, little lesson for you there. As you can see, there's quite a lot of welding involved in joining the shank and the nose together. And then once we've got it welded up and we're happy with it, we grind it back off on the outside just to make it nice and smooth. It's more just for personal preference than anything, but the idea is the weld is as good as the steel either side, so if it's ground back properly, in theory you shouldn't be able to tell where it's been joined. Now it's run on, run off tabs cut off and ground off, ready to fit the shroud and the nose. Just to make sure they fit, this shroud actually is held on by two round slugs either side at the top. And then now we're on to the headstock. as you'll have been able to see, there's been quite a bit of die grinding going on, putting these bosses together, and unfortunately for some reason on this particular job the cut quality on these pieces aren't very good. Normally we don't suffer at all with cut quality where we get our stuff CNC, whether the machine man was having a bad day or what, I don't know. But anyway, when my life's difficult, so it's adding to a bit of extra content, I suppose. But yeah, anyway, we've got 3 bosses diagrammed in, just the back one left to do, so we'll get that in. Hopefully everything will be square still, and then we'll be good to go. So now that we've got the head tack together, we're going to turn it upside down and stick the tooth on, or the shank, and the gussets to save us having to brace that up to weld the headstock up. We might as well use the natural bracing that we'll have when we fit the shank to save putting braces on, cut off and start again. And it was at this point we realised the crane unfortunately wouldn't lift the shank, so we had to bring back in the forklift to set the shank on top of the headstock. So once we've got it all marked out nice and get it set on and tacked up. So we've got the shank on the top of the headstock now. So what I'm going to do is I'm going to weld around the gussets first of all to stop the plate for the head pulling, and then once I've welded around the gussets to give it enough support, and obviously weld the diagonal of the shank to hold the shank on properly. As you can see, there's quite a lot of welding involved in this part too. There's roughly 44 runs of weld in each side of this shank, so as you can imagine, it takes quite a while. So we're just on to our third roll of wire on this job so far. As you can see here, there's you often see me chipping away a little bit. Wire brushing, you do find that you get a few impurities coming out all the time, mainly from the welding wire, to be fair, but it's always nice just to keep your weld as clean as you possibly can, obviously to keep the strength there and keep the job right. For those of you that are wondering why we're cutting a lump of tube in half, we're cutting this lump of tube in half to go in between the ears on the head as a brace rather than a lump of flat. Just if anybody's manhandling this with the forks, it will just ride over the tube as opposed to crashing into a bit of flat that's stuck up in between the pins, as well as it has just as much, if not more, strength, and looks quite different as well. And as you can see here, this is me putting a bit of tube in between. Like I say, it's just a brace to go between the ears, and that'll just stop everything from moving and keep everything right and square. So I've got the quickie burner set up behind us to cut out some triangles for some gussets to go on the side of the river tooth. So we do get most of our stuff CNC'd, but sometimes either the part's missing, hadn't been thought about maybe, or incorrect, so we have to improvise. And the little quickie burner that you can see here is always our friend in these cases, because as far as I'm concerned, it doesn't matter how steady your hand is, you ain't as steady as this machine. What a cut it makes. Talk you through the shroud. Obviously the tooth or the point fits on first, and then we have this cover or shroud as we call them. We've gone with the MTG style on this one, which different to a lot of others. You weld these slugs on the top that go in this slot, and then you just have one pin in the bottom which holds it on. So once this slug's welded on there and that pin drops in there, you turn that a quarter turn with a big bar, and it has a plastic collar that notches it in so it can't just undo on its own. But that retaining pin, due to the geometry of it, means that them slugs will stop that coming forward. So for all they're solid, nothing can move until you take that pin out. But also, as extra security, your tooth fits over here onto the base of this bit. So again, you've got to have the tooth off as well. So it just gives you that little bit of extra security of that not being able to come off, because all the wear of the ripper is on the tooth, which you could just as say see in the background over there, look on the bench. All the wear's in the tooth and that shroud. Of course, as your earth, rock, whatever, moves over here, there's this big gap. So all of this area doesn't really get touched. Unless you're in a really, really strange going that molds around it as it goes. You have like a cavity there where nothing touches. So that's basically the meaning for that shroud, is to stop the wear of the actual ripper behind. So that's a I can get my words out. That is a replaceable wearing part. So I'm just unfitting that at the moment. I've welded the slug on the other side, obviously turned it over, and we're going to weld that slug on, and then that can come back off again and go back on once it's done. We've just the bosses left to weld in now. We've obviously prepped and welded the nose to the shank, welded the shank to the head, and welded the head plates to the backing plate of the head, gusseted it all up. We've put these slugs on to retain the shroud of them, or the cover, but just an insight to anybody that's not very familiar with welding. A spool of welding wire weighs 15 kilos. So as we weld with the MIG, obviously the spool of wire is what we're laying down. On this particular job, we've used up to now approximately 5 rolls of wire, which is the equivalent of 75 kilos. So there's 75 kilos of welding wire in this job. Obviously, this main part of the shank weighs just over 600 kilos, and there's similar weight in the head with all the parts together. So we're looking, by the time we've finished with the whole job, with the shroud and the tooth on, that it's about 1.6 tons. Now, as far as welding goes, I lost count of the amount of runs that's in there between this bit and the nose, but in the tops of here, there's 19 runs on each side of these heads. There's 44 runs on each side of where the shanks to the base plate. All the gussets have 6 runs of weld around them, and once we put the bosses in, we'll know how many runs is around them. But yeah, it just gives you an idea of, obviously multi-layered welds round, and you obviously heap your welds, so you start with 1, 2, 3, and so on and so forth, which gives you obviously the triangle effect of how much weld you have on. So just a little insight to how it goes down. So there we have it. It's all welded up and finished and in paint. So now just to put the shroud and the point on, and we have the finished product. 2 of both going to the same quarry. Thanks for watching. See you on the next one.